Okay, now what if the involved forces are already inclined? Just like what we have here in problem number 7. So before we proceed to the solution, so allow me to read first this problem. The resultant of the force system shown in the figure acts in the horizontal plane and passes through point D. If the value of T, which is this, is 146 Newton, we are asked to find the value of F and then the value of P. So in the current figure, the resultant force is not given only its direction. So it is purely horizontal and then at the same time passes through point D, which is this point. Okay, so we are asked to find two values here. First is the value of F and then the other is the value of P. Okay, so most likely ang magiging problema natin dito when it comes to computing the moment of force is the moment arm. Now remember that the formula that we need to use in computing the moment is force times distance. Okay, so the distance must be perpendicular. This is just a refreshment about the process in computing the moment of force. So the moment r must be the distance that is perpendicular with the line of action of the force. Okay, so paano ang approach kapag ang force this time ay inclined? So definitely, we cannot anymore use the formula since the moment arm nga can't be computed no based on our current figure. So what we need to do every time we are encountering forces that are inclined is to use a theorem which is called Varignon's theorem. Okay, so this is always the approach that we need to apply every time we are encountering inclined forces. Okay, and then we want to get the moment. Now, this theorem states that the resultant moment is also equal to the algebraic sum of the moments generated by these components. So, ibig sabihin, if, for example, for further illustration, we have only one force, okay, which is force R. Now, and then let us say that point O is the point of rotation. So definitely, if we still want to use the formula in computing the moment of force, which is force times distance, so the force is definitely the magnitude of R, and then the moment arm or the distance that is perpendicular with the line of action of the force involved, which is R, the moment arm or the distance that is perpendicular with the line of action of R is definitely D. So meaning to say, we can definitely use the formula which is force times distance kasi pareha silang given. Okay, so therefore, all we need to do is just analyze the orientation of the rotation which is clockwise and then that's it. Okay, we can definitely compute the moment of force, okay, about point O by simply using this formula. Now, what if the moment arm is unknown? For example, that is the usual case if the force is inclined. Okay, kasi usually kapag distance or moment arm, dalawa lang yung pwedeng maging orientation niyan. Most of the time, no, hindi at all times. No, horizontal or either vertical. So ganito yung approach natin. So what we need to do is to split the inclined force into its component. So allow me to display another figure on this side, but this time not in terms of the resultant of the force involved. So this time in terms of its respective horizontal and then vertical component. So Rx and then Ry. Now, let us say that the horizontal distance from the point at which the force is acting to point O is x, and then the vertical distance from this point to point O as y. So horizontal distance is x whereas the vertical distance is y. Now, if we want to compute again the moment generated by the inclined force about point O, but this time in terms of its component, pwede pa rin. As long as we are conforming to the rule, or as long as we are conforming to the principle that the moment arm or the distance is the distance that is perpendicular with the line of action of the force involved. For example, if we want to get the moment that is generated by the x component of force R about point O, definitely y is the moment arm. Why? Because this is the distance that is perpendicular with respect to its line of action. And then if we want to get the moment that is generated by the y component about the same point, so I think that everyone will agree that the moment arm is x, because this is the distance that is perpendicular with its line of action. So in terms of rotation naman, so if we want to analyze the rotation of the moment to be generated by the x component of r, so we will encounter a clockwise rotation. And then if we want to analyze the rotation that the y component of r generates about point O, so we will also encounter a clockwise sense of rotation. So definitely, aside from referring to the original orientation of the force, which is inclined, we can also focus on its components and then compute the moment. Okay, so therefore, by getting the moment about point O due to the components of R, so definitely Rx is the moment generated by Rx is Rx, which is the magnitude of the force involved, and then the moment arm is Y, and then which is this one, and then the moment generated by the Y component, okay, about point O, the magnitude is Ry, and then the moment arm is X. Okay, just like this one. Now, based on this theorem, which is Varignon's, okay, definitely, the moment that we computed about point O due to the resultant force, which is inclined R, and then the moment that we get about point O that is generated by the components of the inclined force equal lang. Yun ang ibig sabihin or gustong iparating ng Varignon's theorem. So therefore, if this is computed using this formula, and if this is computed using this formula, so therefore, by simplification, we will be having this equation. So this is going to be the equation or the principle that we will be applying to compute the current problem, which is problem number 7. Okay, so let's try to apply that here for appreciation. So let's continue solving problem number 7. So let us try to compute muna the moment generated by the individual forces. Okay, so in this case hindi na isang inclined force lang ang involved, tatlo na, pero yung concept ng Varignon's applicable pa rin siya. So all we need to do is to split muna each inclined force into its respective horizontal and then vertical component. Pero bago yon, so let us use equation to represent the moments to be generated by the three inclined forces. So definitely, the point of rotation that we will be using is point D. Okay, why? Because the resultant force, as the problem specified, is passing through point D. Okay, so we will use that concept later on. Now, why we chose point D as our point of rotation. Okay, explain natin yan later. Now, if the point of rotation is point D, so meaning to say the moment to be generated by force T about point D, and then plus the moment generated about point D due to force F, and then plus the moment generated by force P about point D. So just get the summation. So what we will have in terms of equation is this. Okay, so this is the total moment due to the individual forces. Okay, so all we need to do is to compute each term. Okay, so definitely we have three terms. So the first term is the moment generated by force F. The second term is the moment generated by force P. And then definitely the last term is the moment generated by force T. Now, let us try to compute first the first term. So isolate na muna natin yung figure, no? But this time, yung force F lang yung nag-aak. Okay? So since this is inclined, so definitely we need to display its x and then y components. So let's name the x component as fx and then the vertical component as fy. Okay, so therefore, before we get the moment or the sum of the moments generated by the components about point D, so let us compute first the x and then the y component, and then to be expressed as the function of f. Okay, so therefore, what we need to do is to display first the slope. So definitely that is 2 vertical to 2 horizontal. Okay, so therefore, to determine the x component, so the ideal approach is ratio in proportion. So the two here is the vertical side of the slope, and then definitely multiplied by the magnitude of the inclined force, which is F. And then D here is the hypotenuse side of the slope, which is computed definitely by using Pythagorean theorem, square root of 2 square plus 2 square. So by using our calculator, it is going to be equal to 0.7071 F. And then since the okay, sorry. This is supposed to be the horizontal side of the slope, not the vertical. Okay, sorry for that's the correction that I need to correct. Okay, from my earlier statement. Okay, anyway. So if we want to compute the vertical component, equal lang sila. So definitely the vertical side of the slope is 2 pa rin, and then multiplied by the magnitude of the force, and then D is the hypotenuse side of the slope, which is still computed using Pythagorean theorem. So equal lang sila ng value. Now, since nakuha na natin yung values ng x at saka ng y component as the function of f, so let us try to analyze the rotation of the moment, no, about point D generated by the x and then the y. Okay, now let us start with the moment generated by the x component. So definitely the moment arm, if the magnitude is fx, the moment arm is 1, 2, 3, 4, 5. Now 5 is the moment arm because this distance is the distance that is perpendicular to the line of action of fx. And then the rotation is counterclockwise. Okay. Next is the moment to be generated by the y component of f, which is fy. Now, the moment arm is definitely the shortest distance from point A to point D. Okay, so that is simply 1. And then the rotation is this time clockwise. Okay, clockwise. So since this is counterclockwise, negative, and then the formula will be fx and then multiplied by 5. And then since this is clockwise, so therefore positive, so the formula will be fy multiplied by 1. So in terms of equation, we will be having this. Okay, so therefore just substitute the value. So remember, this is again fx multiplied by the moment arm, which is 5, whereas this one is fy multiplied by the moment arm, which is 1. Now take note that fx is just computed earlier. So let us go back to the previous slide. The value again is this. Okay, so therefore i-substitute natin. So this is equivalent to 0.7071 F. And then i-substitute natin yung moment no, na nakuha natin via focusing on the y component. So again, that is equivalent to Fy multiplied by the moment arm, which is 1. So Fy is also equivalent to Fx. So substitute lang natin and then simplify natin since both of them can be combined since they have the same variable. So the simplified value is equivalent to negative 2.8284 F. Okay, so this is the moment generated by the inclined force F. So remember that we computed it by just simply focusing on the components of the inclined force F. Now let us proceed to the moment to be generated by force P. Okay, that is acting at point B. Okay, so what we need to do is to isolate again the figure, but this time with the only with the involved force only. Okay, so therefore we will be having this. So since this is inclined, so what we need to do is to display again its x and then y components. So definitely the x component is left, its y component is down. And then let us try to compute their values as the function of the inclined force P. Okay. Now, focus na muna tayo doon sa slope ng inclined force. So, by focusing on the line of action, which is this one, the broken line. So, the slope, the vertical side is 2, and then the horizontal is 3. So, 2 is 2, 3. So, we need these values for us to be able to compute the values of the x and then the y as the function of P. Okay, so definitely the x component of P is 3, which is the x component of the slope, multiplied by the magnitude and then divided by the hypotenuse side of the slope, which is D. So D is definitely can be computed using Pythagorean theorem. So that is 2 square root of 2 square plus 3 square. So since P is unknown, so simplify na lang natin. So that is also equivalent to 0.8321 P. And then for us to have the value of Y, so definitely that is vertical side of the slope, which is 2 multiplied by P and then over D, which is again the hypotenuse side of the slope, which is computed using this. Okay, so therefore use our calculator. So that is simply equivalent to 0.5547 P. Okay, now let us analyze now the rotations of the two components about point P. Okay, now let us start with analyzing the rotation to be generated by the x component about point D. So that is clockwise, and then the moment arm is 3. Now it is the vertical distance definitely from point B to point D. So again, the reason why this is the moment arm, because this is the distance that is perpendicular with the line of action of the x component of P. And then the rotation is clockwise definitely. So this is the moment generated by the x component. So again, that is P sub x times the moment arm 3. Now next is the moment generated by the y component of P. So the rotation is counterclockwise, so meaning to say negative, and then the moment arm is definitely 1, 2. Okay, so the moment arm is 2, and then the rotation is counterclockwise. So that is going to be positive, and then minus, or rather plus, and then minus. Okay, so again, this is computed by getting the product of P sub x and then 3, and then this is computed using the product of P sub y and then 2. And then take note that since this is positive, this is clockwise rather positive, and then since this is counterclockwise negative, or this in terms of equation. So substitute natin yung moment na na-generate ng x component. So that is again P sub x times 3. And then P sub x is again expressed as the function of P, which is this. So substitute natin yan. Okay, so if this is also equivalent to this, okay, so dead end kasi we do not have the value of P. And then let us proceed now in substituting now the moment that is generated by the y component of P. So this is again equal to Py multiplied by the moment arm, which is 2. And then remember that we also get the expression of Py as the function of P. So doon sa previous slide, that is also equivalent to 0.5547P. So i-substitute natin dito. Okay, substitute, and then take note that since both terms are expressed in the same variable, pwede natin silang pagsamahin. So by using our calculator, okay, this and then minus this, so that is equivalent to 1.3869P. So we computed already the moment that is generated by force P alone. So mayroon pa tayong isa pang natitira, and that is force T. Okay, that is acting at point C. So ganun pa rin, i-isolate natin, and then take note that its magnitude is given this time. So that is equivalent to 146 Newton. Okay. Now, i-display natin ulit yung figure, but this time with force T acting alone. So again, it is inclined, so we need to display its x and then y component, which is rightward and then upward respectively. Okay, now in computing the x and then the y component, so what we need to do is to compute first now the x and then the y side of the slope. So definitely that is 4 vertical to 1 horizontal. And then in computing again tx ratio in proportion. So that is the horizontal side of the slope, which is 1, and then multiplied by t over d. So d is again computed using Pythagorean theorem. So, and then T is again given, the magnitude of T is given, so that is equivalent to 146. And then D is square root of 1 square plus 4 square. So definitely we will be having 35.41 Newton as the resulting value of Tx. And then in computing the y component, so that is again by using ratio in proportion. So vertical side of the slope, which is 4 times T. Okay, and then over D, which is the hypotenuse side of the slope. So T is again 146, and then D is square root of 1 square plus 4 square. So this is equivalent to 141.64. Now, in terms of rotation or in terms of moment, let us check this time the moment to be generated by the X and then Y component of T about point D. Now, definitely, T sub X will not generate moment about point D. Why? Because it is passing through the point of interest. Walang moment arm. Automatic 0. Okay, now, the Y component of T, on the other hand, will generate a moment. Okay, definitely magkakaroon ng moment yan. And then the rotation is counterclockwise. Now, what will be the moment arm? The moment arm is definitely 1, 2, and then 3. Okay, so that is 3 unit length. Okay, so therefore, in terms of equation, okay, we will be having this. So remember that there is no moment generated by the x component. So this is definitely equivalent to 0. And then this is negative because the rotation of the moment is counterclockwise. So this is again Ty multiplied by the moment arm, which is 3. Now remember that the value of Ty is already computed from the previous slide. So that is again equal to 141.64. Okay, so substitute the value of Ty and then simplify by using again our calculator. Its value is negative 424.92. Okay, so take note, just an update, we have computed already the moments that are generated by the 3 inclined forces. So this is the moment generated by inclined force F. And then next is this, which is the moment generated by inclined force P. And then lastly is this, okay, which is the moment generated by inclined force T. Now, how will we be able to compute the magnitude of P and then F Okay, remember that when we talk about the concept of Varignon's theorem, sabi diyan, the resultant moment is also equal to the algebraic sum of the moments generated by its component. Okay, so meaning to say, in terms of equation, we will be having this. So the resultant moment generated, okay, or the moment generated by the resultant about point B is also equivalent to the moments generated by the individual forces, which is this. Okay, so take note that we have already computed this, the first term, the second term, and then the third term. Now, paano yung moment na na-generate ng resultant force about point D? Okay, so we will finally answer now why we chose point D as our point of rotation. So the reason why we chose this as our point of rotation is because of the fact that the resultant force is passing through this point. Now, aside from it is horizontal, it is also passing through point D. Ibig sabihin, if the resultant force is passing through point D, it will not generate moment. Okay, kasi nga walang moment arm. Walang distance from the line of action of the resultant force to the point of interest, which is point D. So this explains why we chose point D as our moment center. Because of the fact that the moment arm, okay, moment arm from the resultant force to this point, 0 siya. Okay, and because of that, walang magiging moment. Okay, so let us substitute. So if this is R multiplied by D, R is the resultant force, D is 0. So again, the reason why it is 0 is because the resultant force is passing through point D. And then i-substitute natin yung moment na na-generate ng force F. So balikan natin yung previous slide. So that is again equivalent to this, negative 2.8284 F. Okay, substitute natin. And the next is the moment generated by inclined force P. So that is equivalent to this, positive 1.3869 P. Okay, and the next is this. So this is equivalent to negative 424.92. Okay, so if this is 0, the left side of the equation is 0. So we can simplify that into this. And then let us transpose this negative 424.92 on the left side of the equation. So we will be having this. Now, since this equation contains two unknown, can't be solved. So let's name this as our equation 1. Okay, so paano natin makukuha yung value ng two unknown inclined forces, which are F and then P? Now, remember that the orientation of the resultant force is specified. The direction that it is horizontal is specified. So kahit unknown yung magnitude ng resultant force, okay lang. Kasi yung direction niya in-specify naman it is horizontal. It doesn't matter if the direction is rightward or leftward. Okay, kasi nga, if the resultant force is acting horizontally, meaning to say, the resultant force is also equivalent to its resultant, or rather the horizontal force is also equivalent to its x component rather. Okay, so again, the resultant is also equivalent to its x component. And if the resultant force is equivalent to its x component, its y component is definitely equal to 0. Okay, why? Because the resultant is purely horizontal. Okay, so if you can still remember, the process in computing Ry is just vector summation of forces acting vertically. Okay, so therefore, or this one. So if the value is equivalent to 0, so ang gagawin na lang natin, get the vector summation of the vertical forces that are present in our force system, which are 3. Okay, so first is this, the vertical component of F, the vertical component of P, and then the vertical component of T. Now take note that the vertical component of F is downward, that is negative. The vertical component of P is downward as well, so that is negative also. And then the vertical component of P, which is upward, so that is positive. Now, the vertical component of F is also equivalent to this, 0.7071 F. And then the vertical component of P, okay, so let us proceed to the previous slide, this one. This is the magnitude, okay, or this is the expression as the function of P. So that is 0.5547. And the next is the value of the y component of T. So that is equivalent to 141.64. Okay, so ang gawin natin, i-substitute lang natin sila. So again, this is negative Fy minus Py plus Ty. And then Fy again is this, Py is this, and then Ty is this, 141. Okay, or this one. Okay, so what we need to do here to simplify the orientation is let us transpose this and then this on the right side of the equation, we will be having this. Okay, so since still two unknowns are involved within the equation, can't be solved, so let's name this as equation 2. Pero since we have already our equation 1 containing the same unknown variables, we can definitely use either elimination or substitution to finally compute the magnitude of F and then P. Okay, so it's either elimination or substitution. So in my case, I used elimination. Okay, so again, this is our equation 1 and then this is our equation 2. So what we need to do is let for the example, we want to eliminate variable F. So ang kailangan nating ditong gawin, kailangan na muna nating baguhin yung numerical coefficient niya na 0.7071. Kailangan natin itong gawing kaparehas ng numerical coefficient nung F doon sa first equation. No? But opposite in sign definitely para ma-cancel out. That is positive 2.8284. So what we need to do is to normalize first F. So when we say normalize, dapat yung maging numerical coefficient niya maging 1. So since the current numerical coefficient is 0.7071, so we need to divide it by its own, which is 0.7071. Yun nga lang kasi, we need to distribute it to the entire equation para hindi ma-compromise yung integrity niya. And then, definitely, by multiplying this by 1 over 0.7071, magiging 1 na siya. And then, para maging 2.8284, so we need to multiply the equation again by 2.8284. Okay, so therefore, distribute lang. So magiging ganito yung second equation natin. Okay, so magkamukha na yung numerical coefficient ng first equation at saka ng second equation but opposite in sign. Definitely, cancel out na agad siya. And then get the summation of this and then this. So that is equivalent to 3.6057p. And then let's get also the summation of this and then this. So that is equivalent to 991.48. So definitely, we can finally compute the value of P by dividing both sides by the numerical coefficient of P, which is 3.6057. So P is equivalent to 274.98 Newton. Now, to compute the magnitude of P, so either we use equation 1 or equation 2, tapos substitute natin yung nakuha nating P. So let us use equation 1 na lang and then substitute natin yung nakuhang magnitude ng P. One equation, one unknown, we will finally have the magnitude of F, which is negative 15.40. So this is the approach that we need to apply every time we are encountering inclined forces and then we are asked to find the moment.